Now come to discuss the software architecture styles, or in simple words, architecture patterns. An architecture style, which is also known as architecture pattern. In this context, we are talking about software architecture pattern. Abstracts the common property of family of similar designs, that is contain a set of rules, constraints and patterns of how to structure a system into set of elements and connectors. Remember that whenever we develop a system, we design and develop a system, we either directly or indirectly adopt certain pattern. Pattern is basically the mechanism which tells us, which guides us how to connect different elements using connectors, and this architecture is applicable for a variety of designs, similar designs. So this means every design fit into either any of the architecture pattern. Architecture style shows constituent elements types and their runtime interaction of flow control and data transfer. So it guides us. The runtime, it tells us about the runtime interaction of the flow of control. Flow of control means the communication of different components or modules together. So how different components, modules, the data storage is designed. So this is about the architecture style. The key components of architecture styles are the elements, which are in short words the components, the different components, connectors, which connects two elements, any elements of the software, constraints, that are any rules, any constraint that are imposed on the software design. The constraints can be on the data server, the data storage device, or on the client side, and the attributes. So we have different architecture variants or architecture styles available, like pipe and filter, layer base, shared repository, etc. In this lecture and in onward lectures, we'll more talk about the different architecture styles in quite detail. So these are the different architecture styles. Data center based approach, which will be covered in this today's lecture. A data flow architecture will be covered in today's lecture, which contains the batch sequential, pipe and filter, process control. Then we have a data center based data center oriented architecture styles, which further have two categories, either repository style or blackboard. Then we have hierarchical architecture styles, and then distributed architecture styles. This not ends here, but we have also interaction oriented software architecture design, which tells us the interaction of user with the system, the interaction of interface with the components. So further we have MVC and PEC architecture style. Each style has a set of quality attribute that it promotes. This means that every architecture style have certain qualities which differ the particular architecture style from the other architecture pattern. But remember that our requirements or software does not fit in all the architecture, or we can say that either we can design a software in many architectural styles, but it is only best fit with the one particular style, not with all. Architecture style are domain independent. It is also true that an architecture style may be applied to many application domain. This is not necessary that it is typically for web or mobile application. So inside web application we can have many patterns, and inside mobile application we can also have many application. For bigger projects as compared to small, we can apply different methods. So we cannot say this is applicable for small only, this is for large only. The choice of particular software architecture is made on the basis of overall system organization, how different module works, how user interact, how the data is passed to the server, and the domain overall, the overall system organization policies also matters, and the constraints such as one client will not see other data, one can see the other data, client can be active, client can be passive, data server can be active, can be passive. So there are possible constraints that are imposed, and then it become the base of the selection of different architecture style. There is no single fit perfect architecture. As I stated earlier, over the time several different software architecture have been created, even have strength and weakness. One more thing you should remember, that we can design a software in more than 2 architecture patterns, like on oriented software design architecture pattern is selected, and for data flow we select particular style, and then we can combine more than one pattern. So for each style we will identify the components, connector, advantages and disadvantages. Remember that every pattern possesses some advantages and disadvantages. So this then depends on the circumstances. So if or achieving the benefits is more necessary than the drawbacks or disadvantage it has, so we will go to that architecture pattern based on the advantages. But if the disadvantages are heavier, so we can stop selecting that architecture and then should prefer some other architecture pattern. Now come to discuss the data flow architecture. As the name shows, data flow. In data flow architecture, the whole software system is seen as a series of transformation on the consecutive pieces of set of input data. So this architecture depend on the flow of data. How data flow? Either data flow in sequence from one unit to another, or it can run in a parallel. Has the goal of modifiability. So the goal is that we can modify the architecture. If we want to replace some element, so we can. So this is the beauty of this architecture pattern. It is a series of transformation applied on successive piece of input data. Data comes, process, and then output is generated, and then that output is the base of that output become the input for other process. So data enter the systems and then flows through the components at one time until they are assigned to the output or data storage. So this means from initial input to the final storage, the data will process and will pass from several units, several components, either in sequence or either in a parallel. So subsystems are independent. Remember that the subsystem, subunits, subsystems that comprise the data flow architecture are not depend on each other. Remember that independency here means that there are specific roles of each subsystem, and if there is some problem in some particular subsystem, then we can easily replace it. High modifiability. So modifiability is the main goal of data flow architecture. Example of this data flow architecture include the banking system, the business batch processing. A banking system, you know, when you want to submit, when you want to credit your account, you go, you fill the form, you go to some counter, they stamp it, sign it, go to some other counter, they make and they further make your entry, and then money is processed. If you want to withdraw some money, so there is a sequence of steps included. So basic business batch processing, any business processing depends on the business policy, so it is not a random process but step by step data flow. So this means if we randomly go to some process, so this means the data will be either incorrect or will be not inserted if we have not followed the sequence from the start. So this means the data flow is not random but it is planned and it is executed in process accordingly. So the big question is the direction of data flow. So three subcategories, but here I will discuss in more detail about the two basic data flow architecture style which is normally followed. One is the batch sequential and another is a pipe and filter architecture style. Batch sequential, traditional data process model that was invented or widely used in era of 1950 to 1970. This means this is not like today or not followed too much because of certain disadvantages which I will discuss with you in this lecture. It carries a batch of data as a whole from one subsystem to another. Why it is called batch sequence? Sequence means one after another, and batch means a junction of data is processed, batch of data. This means batch means that contain a similar data, similar purpose data. Whole data is for one same purpose that is processed in sequence. Each data transformation subsystem or module cannot start its process until its previous system completes its computation, and this is very important point. This means any process here depends on the previous. If there is no previous process, that is the initial node or subsystem, and then that actually initiate the process. So example is banking system. Banking system, as I told you that it is in a series of batch sequence. It consists of particular process which receive input and then process it, and then after the process the data is passed to the another subsystem, and then in this way data process in sequence until the final output is generated and then goes to the data storing devices. Utility billing system. So first your units are calculated, and then based on certain rules imposed by the government, like if the units are less than 100, between 100 and 150, commercial or not commercial, factory or domestic, etc., and then based on that the bill is calculated, and the previous account bill is also checked. If you have not paid, so then those debits are also added. So this is in the sequence. Advantages. The main benefit are division of task is easier. So we easily divide task 1, task 2, task 3 in sequence. That is the easier. This means the management is easier, and modifiability is the benefit. Each subsystem can be easily replaced if there is some need of modification. Each subsystem can be individual program that receive input and process it to generate the output. Limitation or disadvantage include it does not provide interactive interfaces. So this means it depends on the subunit systems, internal processing occurs, and this is the limitation. Implementation depends on the previous subsystem. So this means if there is some error or delay in the previous system process, so this means the current or the next subsystem will be not executed. This means thus the performance is a big issue, the speed is the issue, because the subsystem depends on the previous. So if there is a delay or the connector is not connecting to components, data cannot be processed, and there is a limitation. Concurrency is not supported. This means parallel execution is not supported. This means two subunits or more than two subunits cannot process the data in parallel, cannot work on the data in parallel, but rather the subsystem will depend on the previous. So this means if there is no concurrency, so it affects the speed. So this means low speed and performance is the issue. Now come to discuss the pipe and filter architecture. Concurrency and incremental execution. This is the advantage. So this means pipe and filter. What is pipe and what is filter, that will be discussed shortly. But here two or more than two subsystem can work in parallel, and incremental execution. This means execution in increments is also possible. The main components include filter and pipe. Pipe is actually the communication channel that allow data flow from one subunit to another, and filter is the computing component. This means any component that computes on data, that process the data, and based on the instruction and based on the input received. So filter function is to process, filtration. Data stream is first in first out buffer, so it work on a first in first out process. So if the data come first, so it will be first out. So pipe and filter concept, we have two filter 1, filter 2. Filter 1 here is a source and filter 2 is a sink. Sink means it will receive a data from the filter 1 through a pipe. So filter 1 may be send data to filter 2, filter 2 may only receive data from filter 1. So this, remember that filter 2 can be designed for the purpose of receiving data only from filter 1, or filter 1 is designed only for the purpose to send data to filter 2. Filter 1 may not receive data. This means that filter 1 purpose is only to send data, not receiving, and filter 2 may not send data. This means filter 2 will act as a sink. Sink means it absorbs data and it does not produce or generate data, but so there can be many possibilities for both the filters. Pipe is a data transport mechanism. Example of pipe and filter architecture is, for example, if you want to convert the characters to uppercase, so you will apply the formulas, you will apply the functions, and the data input is in the form of lowercase or mixture of lowercase and uppercase. So filter will process and will convert it to uppercase, then it will move toward another subcomponent, and that is matching. Matching means first remember that the function of this whole system is to convert document character to uppercase and then count the occurrence of AE characters. So first it will convert input characters to uppercase, and then in each and every character will be compared with either A and B. If it match with either A or E, so this means the counter will be incremented. So uppercase conversion, second filter task. The first filter task is to convert the letters to uppercase. The second core or component task is to match the character with either A and E, and then the third is to sort and count. So what does sort means? Sort means first A can be selected, and then E can be selected, and then A and E are counted, and the data syncs. So data syncs means the data are absorbed, and this filter does not further process the data. So billing system also work in the same. Billing system can be work in the same process, that such that parallel counters system can work. But remember that parallel execution is possible only when either of the system start work. Pipe and filter sequence diagram. So sequence diagram, what is sequence diagram? Sequence diagram shows all the activities among the objects or classes in sequence. How data is processed from one object of the class to another class object in a sequence. So order is necessary in sequence diagram. So we have first data source, and at the end we have data sink. So one object is for data source, we will take other object for data sink. Inside we have the two filter. First filter will read the data from data source, and then this sign show that this sign show that the data is processed. So it will definitely take time. So after processing and after calculation or computation, it will process using the pipe. So it will further take time, and then will data will be read by the filter 2, and then after processing data is sync, means write. So for data sync we use the write, and for data from data source we use the read. So this means from data source we read the data and we write data to the data sink. So this is the simple diagram: data source, filter 1, filter 2, inside we have pipe which is communication path, and data sink. So this is the modified diagram. You can see data can be blocked, data can be further checked. Remember, there is coming a good example in my mind. Printers, digital printers or photostat machines also work on pipe and filter architecture. How? Suppose we have a printer and we have put a constraint on it that we cannot print more than 100 pages per day, and we have multiple computers connected. So filter 1 will first check. Filter 1 will first receive the data from particular system. First, if PC 1, computer 1 instruction is coming first from computer 1, so it will be put in put here, then computer 2, computer 3, and then for each and every computer the filter will check either the particular user is exceeding his daily limit or not. So if daily limit is exceeding, so it will stop there. So printer receive instruction from multiple computers, then process it and pass to other filter, and further action is based on the instructions. Similarly, digital photostat machines, similarly microwave oven, we give some input, and then based on the input filter execute the data, process the data, and pass from one unit to another. Similarly, we have a good example. We can take a good example of digital washing machine, where first it will take coin will be compared. If the coins are enough, so this means further the process will be executed. You put your clothes, and further clothes putting process and then washing process also takes in the sequence, and then hot water comes, then soap will come, and then clothes will be washed. After washing, it will be checked that either the washing process is enough or not, and then further clothes will come to a dryer and then will be processed. So we can take too many examples from surroundings. The advantage of this pipe and filter is cohesive style. Cohesive style means there is a strong bonding of different elements of the filter or unit. This means it will depend lowly, or it will less depend on the coupling. This means one component or one filter does not depend on other filter, but rather filter depends on the elements that comprise the particular filter. So this is good. Remember that this is the quality of any component or software, that it possesses less coupling and maximum cohesion, high reusability. If any filter is not working properly, so we can easily modify it, and we can easily reuse the particular filter or combine filters in some other system. But what are the disadvantages? Disadvantage include addition of large number of filter may reduce the performance. So if we put too many filter in the systems, so definitely each filter will take time during computation, during the process, and we know we have a pipe here, so data when passed from one filter to another, pipe will definitely take some time. So if we have system with too many filters, so performance, no doubt their parallel, remember that as compared to batch processing system, this pipe and filter architecture support parallel execution. But still, if we have too many filters, so this means the performance can be affected, can be expensive because of the filter cost, because of the computation included. So definitely it is a costly expense, especially for the large scale filtration process. If there is a large project and which contain too many filters or quite number of numerous filters, then computation and designing of filter can be costly. So this was all about the data flow architecture. So hopefully you enjoyed today's lecture. In next lecture we will talk about more on some other architecture style. Thank you so much for watching my video. Thank you so much.